Hello, I greet all of you today. I want us to see how we can verify Archimedes principle using a cylindrical rod. Before we can really verify the Archimedes principle, we need to know what does Archimedes principle states. Archimedes principle states that when a body is partially or being wholly immersed in a fluid, it experiences an upthrust. Which is equal to weight of fluid displaced. So Archimedes principle simply states that when a body is partially or wholly immersed in a fluid, it experiences an upthrust which is just equal to the weight of the fluid displaced. So let us see how we can really verify the Archimedes principle. To verify is to check whether the Archimedes principle is really true. Now let us use a cylindrical rod. Now let us consider a cylindrical rod of cross-sectional area A and having a height h, being immersed in a fluid of density rho. So let me have a diagram that can clearly show us what I am talking about. So I have a container here. It's the container. I have let's say this is the cylindrical rod. So I have that. This is the liquid of density. Let's have this is can call this level X. This is another level Y. Let's have P1 would be pressure at level Y. Okay, let's also have that P2 becomes pressure at level X. We will have that if this cylinder is of cross-sectional area, the force due to pressure at the bottom is going to be P2A. And of course, pressure is always due to the height. We are saying the cylinder is of height h. Let me call this H naught. And then the pressure at the top is going to be P1A. That is the diagram that is going to guide us. Now, here we are going to get the volume of a fluid displaced. It is true that the volume of a fluid displaced is just equal to the volume of the cylinder. Is equal to volume of a cylinder. The moment you immerse a cylinder in a fluid, it obviously displaces its own volume. Then this gives us that the volume of a fluid displaced becomes AH, which is the volume of a cylinder. So if we know the volume of a fluid displaced, we can be able to get the mass of a fluid. Mass of fluid displaced. This is mass is the same as volume, which is AH. Mass, this is the mass times the density of the fluid. So that becomes the mass of the fluid displaced. From the mass, we can be able to get a weight. Weight of a fluid displaced becomes mass, which is AH rho times acceleration due to gravity. That one becomes the weight of the fluid that has been displaced. Let's move on now, and then we also find upthrust. So upthrust experienced by the cylinder is just equal to the net force, the net upward force on the cylinder. So in this case, to get the net upward force on the cylinder, we can have that F thrust is equal to P2A minus P1A. That will give us the net upward force on the cylinder. So P2 is the pressure at the bottom and it is due to the height H0 plus H. So that becomes H plus H0 times density of the liquid times acceleration due to gravity, then times A. This is pressure at the bottom. It is due to the height H, and for us to get pressure, we get the height times density of the liquid times acceleration due to gravity, of course, times A, since we are looking for the upward force, and this is the downward force. So minus pressure at A at Y is P1, and so that pressure is due to the height H0, and we get it as H0 times density of the liquid times acceleration due to gravity times, of course, A to make the force. So opening this bracket, we shall have H rho GA plus H0 rho GA minus H0 rho GA. So in the end of the day, you will see that this and that will cancel, and then we shall have that F thrust is equal to H rho GA. So you will see that weight F thrust, which is this one, is equal to weight of a fluid displaced, which is equal to H rho GA. And hence, since we have been able to show that F thrust is equal to the weight of a fluid displaced, then that is enough that we have verified Archimedes' principle. Thank you very much.